Hey guys, how's everything going? Let's take a look at number 68, text justification. We're given an array at word and a maximum max width. Format text such that each line has exactly max width characters and is fully justified. Okay. You should pack your words in a greedy approach, that is, pack as many words as you can in each line, and pad extra spaces when necessary. Okay. Extra space between words should be distributed as evenly as possible. If the number of space on the line do not divide evenly between words, the empty slot on the left will be assigned more spaces than the slot on the right. For the last of the word text, it should be left justified and no extra space inserted between words. Okay, so this example, the max width is 16, so space here is 1, 2, 3, 4. Here is 1, 2, 3, 4. 1, 2, and here is 1. So it means if it is not evenly, if it is cannot be distributed evenly, the left side will have more spaces. The last line, yeah, it is only one word, so it has the extra spaces. For example here, for the last line, you'll see that all the extra space will be put on the right. On the left, there will only be one space. Yeah, I think this is just well, we can just cache. We use a temporary array to collect the words, and if we found that it should be we found that if no more words could be put in, we just generate the array and push in the final result, right? Put it, transform it into a string, and just yeah, generate the final result. So I think this is pretty straightforward, but we need to follow we need to implement all the details, and without bugs, it's a little complicated. It's not about algorithms, I think. Anyway, the idea is that we use a chunk. We use a chunk to cache the result, cache the temporary result, and this is the final result for the chunk. And then we loop through all the words. Words.length I plus 1. So, and we need to count the length of all current words, right? So let's say chunk length equals 0, and for each word there will be, let's see if it can be put into the chunk, right? Let's say constant word equals words I if whether word could be put into the chunk. Okay, so if the problem would be if chunk current length plus the new word length and the space between them, right? There will be at least one space between the words, so it will be chunk length plus 1 minus 1. So this would be a length of all of the total chunk after the word is put in. So if it is within max width, then we can just push it, right? Chunk push word and a chunk length plus equals word length. If not, then it means the chunk need to be transformed into a string and reset the chunk, right? So we say flush. There will be a flush, const flush. Transform. After flush, and we need to check this word again, right? Because it's gonna be a new new chunk. So we say I minus 1, right? And okay, now let's transform the chunk into a string. And then we say the chunk will be empty. Okay, because we let it to be const, we say let, okay, chunk equals empty. And chunk length would be 0. Reset. Okay, now we are given array of string. We need to justify the words, which means we need to add extra spaces between them, or there are two rules, which is the lines that are not the last one, which means we need to first try to distribute this space evenly, and the extra space will be put on the left side. But for the last, right? For the last will be every space will be 1, and then extra space will be all put at the last space. And here's actually we need to handle whether it is last or not. Actually, we have a problem here. We need to flush when we when we have traversed all the words. So if I equals words dot length minus 1, else we traverse through we need to flush when all the words are traversed, so we set the I to the maximum word length plus 1. And if I equals word length, we need to flush. And there are two patterns, right? The last row or not. We need to pass it is last flag. And for this one, we say last chunk. For the others, it's not. So now we need to flush. How can we flush this chunk? What I'm thinking is that for each word to the right side, we suppose there is a space. We keep a space array, like const spaces. We use let to make it easier to do modification. For each word, there must be some space, right? For the last word, because the space is distributed evenly, the right space would be just empty, right? So for that case, we say there will be space for every word, right? Array chunk length and fill with empty string, right? Now, if it is last, we just follow the definition and try to change the space array. If it is last row, and every space should be one space, right? Yeah. So for let I equal 0, I smaller than spaces dot length. When we're getting to the last element, so it might be for the spaces that are not the last one, we need to set it to 1, right? Okay, so if I smaller than spaces dot length minus 1, for last row, it might be something like all spaces 1, and it just there will be no extra space, right? Like this one, but only one space here. So the last space is possible to be empty. We need to count on that. Yeah, but for the space other than that, than last one, it must be one space there. Yeah, so let's say if I is smaller than it, then spaces I equals one space. For the other case, if the rest, right? Though, let's say the rest one, const rest, how many spaces are there? It should be max width minus chunks length minus all the spaces, which means for I, if it's 0, there should be no space. For 1, there is already one space. So for the I space, there would be I minus I. So this is the rest space, and the spaces I would be, we will generate rest spaces, and we need another util, which is const generate spaces with a count. If n is 0, we'll return empty. For other cases, we turn array and fill space join. Yeah, and so we just set the last one to generate spaces and rest. Okay, for the oh god, I made a mistake. This is the last. So the last is done. Now let's try to handle the spaces that are not the last row. For that case, for this case, the last one should be last space should be empty, right? Okay, so the best average should be oh, if there is only one, we don't need to do the calculations, right? Okay, so if spaces dot length equals 1, we just update it. Spaces 0 would be generate spaces. How many spaces are there? Max width divided subtracted by chunk length. Yeah, for the other case, we need to catch the best average. Constant base equals, this is all the spaces, divided by, how many spaces are there? Spaces dot length minus 1, right? And it might not be integer, so math floor const, so this is the base, and the rest would be, this is the total space subtracted by base times, how many spaces are there? This is the space. So these spaces will be scattered averagely for the leftmost spaces, right? Okay, so we now update the spaces for that, just like the previous one. Remember, the last one should be empty, so minus 1. A plus. If I is smaller than rest, because it starts from 0, then the final would be rest minus I. Yeah, if this is the case, we update it to spaces I equals generated spaces, base +1. For the other cases, it would be base, right? And finally, generate the string, which is because we have the spaces array with the same amount of the words. We would just say result push the chunk map for each word. It would be a word plus the space, right? Spaces I. Okay, finally we return result. I have tried this problem for some time, for some times, and it is actually, the idea is simple, but it's not that easy to accomplish without any bugs. I hope that this idea is pretty. Hope it could be simple to understand and follow. Let's run the code. Hope it is bug free, but I'm not that confident. Oh yeah, we have got a round answer. Oops. Okay. Oh, we need to join. We forgot to join. Let's run it again. Let's submit. Look how many times I've just submitted with the wrong answer. Ooh. We had got a problem that said invalid array length. 930, 13. Generate space, the rest. Let's copy the input and try to debug. Generate space base +1. It should be let's just console log it. Console log flush chunk. I really want to click the speed up button, but it cost me some money. Okay. This is actually the third example, right? Science is what we understand well. So the chunk is right, but we have some problems when, oh, the last one is wrong. Everything else we do, we have generated the wrong chunk. Wait, we get the word. If I equals word's length, we flush true. It's okay. But for the other case, if word chunk length plus word length plus chunk length -1, no, it should be, because the word isn't in the chunk yet, so it's +1 plus this. There's no -1. Oh, my bad. The interviewer will pick this up, I think. Pay more attention. Oh, it's accepted. So, and we remove the log and to submit. I hope it will just be accepted. Cool, we're accepted. And actually, this is not a problem about algorithm. I think it's just we just need to implement the requirements of the exactly as we were told to. One thing we may learn from this is that just that, like, this is just like the state machine. We just process all the input by chunks, and we found that we need to flush the chunk. We stop and flush it and do it over and over again, and finally we can get the result. It's like usually there are similar problems like processing a long string and collect, and we need to cut down the string when we meet the spaces and do the transformation or do some regular, I don't know, regular expression matching. Anyway, define a temporary chunk and try to match the condition when we need to flush the chunk and do it over again. So this is the basic idea of how I accomplish this problem. So hope it helps. And yeah, that's all for this problem. See you next time. Bye bye.